6.1 Polygons and Angle Sum. So definition of a polygon: a closed plane figure formed by three or more segments. Each segment intersects exactly two other segments at their endpoints. So here we have a polygon. This isn't a closed figure, so it's not a polygon, and not a polygon because two sides intersect between endpoints. It creates two different polygons, but not one singular polygon. So if we're naming this polygon, you have to name them in order now. So if we look at this first one here, we start with D, we go to H, K, M, G, B. So you have to name them in order. So another one could be M, K, H, D, B, G. So you label the letters in order. The sides are pretty easy. So an example, we got DH, so one line here. Another one is HK, then you do KM, MG, BG, and BD. And make sure you put the little line segment on top. And then our angles are pretty easy. So we have angle D, which is this angle, and then angle H, the next one, and then we'll have angle K. And make sure you just label them with the angles in front, with the angle mark in front. Okay, convex or concave. So a convex polygon has no diagonals with points outside the polygon. A concave polygon has at least one diagonal with points outside the polygon. So I think an easy way to remember this, concave, you think of something caving in. So if you look, this is caving inward. This is also caving inward. Okay, so concave, think of caving inward. Convex, nothing caves in. Equilateral polygon is a polygon with all sides congruent. Equilateral. Remember, equilateral, all of the outside sides should be equal, which equiangular, all of the angles should be equal or congruent. Okay, here's a type of new definition. A regular polygon is a polygon that is both equilateral and equiangular. So all of the angles should be equal and all of the sides should also be equal. So make sure you write this down. Okay, how many triangles are formed by the diagonals from one vertex? So this one, we don't have any diagonals from one vertex. Okay, so we only have one figure. My next one, we create two different triangles. So here's one, here's two. My next one, we create 1, 2, 3 triangles. My next one, 1, 2, 3, 4. Oop. And then we got 1, 2, 3, 4, 5, 6. So those are the diagonals from one vertex. Polygon angle sum. So make sure you write this down. So we're determining the sum of all the angles. So if I added all of these angles together, it should be this many degrees in whatever type of figure we're doing. So 12gon means it's going to have 12 different sides. So I want to know how many degrees total is in a 12gon. So where triangles, we were looking at, they should equal 180. Now it's going to be a little different. So my n is going to be the number that the gon is. So I'm going to do 12 minus 2 times 180 degrees. So 12 minus 2 is 10. And then 10 times 180 should be 1800. So it should have that many degrees total out of all of those angles. So there should be 12 angles in it, and it should be 1800 degrees. So 36gon, we're just going to do 36 minus 12 times 180. So 24 times 180. So 4,320 degrees. 11, we're going to do the 11. Oops, I didn't mean to do minus 2. Whoopsies. Fix that one. So 36 minus 2 times 180. Should be 34 times 180. So 34 times 180, 6120. Couldn't even read my own handwriting. So now we got 11 minus 2 times 180. So 11 minus 2, we got 9 times 180. So it should have 1,620 degrees in this one. Okay? Each interior angle of a regular n-gon. So just make sure you write this equation down because we're going to use it in the next example here. So in this, we're going to determine what one single angle degree measure is. So first we're going to figure out how many sides we have. We got 1, 2, 3, 4, 5, 6, 7, 8. So my n is going to be 8 in this one. So I'm going to take 8 minus 2 times 180, that's a times sign, all divided by that 8 again. So I'll have 6 times 180 divided by 8. So 6 times 180, all that divided by 8. So that means one of those measure angles, so let's say if it was measure angle 1, so if we're finding this angle here, is 135 degrees. So that's the equation you use to determine one interior angle of this. So now my next one, I got 1, 2, 3, 4, 5, 6, 7 sides, so my n is 7. So I'm going to take 7 minus 2 times 180, all divided by 7. So 5 times 180 divided by 7. 5 times 180 is 900. 900 divided by 7. So this angle measure is going to be close to 128 degrees. So one angle in that should be 128 degrees. Okay, determine one interior angle measure based on this. So I have, instead of looking at a picture and adding up the sides, it's giving me the sides. So I'm going to use the same equation. So it was n minus 2 times 180, all divided by n. So this one I'm doing 13 minus 2 times 180, all over 13. 13 minus 2 is 11. 11 times 180, 1980 divided by 13. So one angle in this 13 gon is going to be close to 152 degrees. So my 18 gon, I'm going to move it down here, so I'm going to do 18 minus 2, all times 180 divided by that 18 again. So I'll get 16 times 180 divided by 18. So 16 times 180 is this. All of that divided by 18. So one angle in this is going to be 160 degrees. So my last one, we're going to do 144 minus 2 times 180 divided by 144. So I'm going to do, 144 minus 2 is 142, so this one's going to be big on top. So 142 times 180, 25,560, but we still got to divide it by 144. So one angle measure is 177.5 degrees. Okay, what is the measure of angle Y? First, we have to figure out how many sides we got going here. So I got 1, 2, 3, 4, 5 sides. So we're just going to say it's a 5 gon. So we need to figure out how many degrees are in this the interior here. So we're going to use the equation from before to determine how many degrees is in the inside of this. So n minus 2 times 180. So n minus 2 all times 180. So my n is going to be 5 because we determined it's a 5 gon. So 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180. So there should be a total of 540 degrees in this polygon. So let's figure out how much we have. So first off, we have 110. We have 120. We have 150. We have 90. Don't forget about my little square over there. And then we have this x value that we're trying to figure out. And it should total out to be 540. So let's go ahead and solve for x, which I'm going to do super quick here. So when I added all those together, I get 470. So let's subtract 470 from both sides. So I should get x equals 70 degrees. So that means the measure of angle y, I'm going to replace it to what I'm supposed to call it. So the measure of angle y is 70 degrees. And last but not least, the polygon exterior angle sum. So any polygon that I have, all of my exterior angles, so 80 is an exterior angle, 150 is an exterior angle, and 130 is an exterior angle. If I added them all together, they will always equal 360 degrees. So my exterior angle 115, 75, 99, and 71, if I added them all together, it should give me 360 degrees. And last but not least, each exterior angle of a regular non-gon, so any number, but it has to be a regular one, so it has to be equilateral and equal angular. If you take 360 degrees divided by however many sides it has, you should get the degrees of the exterior, since we're talking about exterior, of the regular non-gon. So make sure you write these equations down.